of a power function. Definition of a power function. A power function is a polynomial of degree n where a, b, c, d, and e are all 0. It's a single term. A power function is a single term. This is a power function. For example, this is a power function 7x cubed. This is a power function negative 4x squared. Here's the deal. Every polynomial function has its own power function associated to it. This is important information. So example number 1, if I have this 6th degree polynomial, 5x to the 6th, ... I don't need to read that out. Its power function that is related to that is just the first term. This is the power function for this function. Clearly, they are not equal. They're not the same. Oh heavens to Betsy, they're not the same at all. But we need to make that statement that f of x certainly isn't equal to g of x. That's like a does statement. But what is pretty cool about this, the polynomial's power function will behave like the polynomial when x is really big or when x is really small. We haven't really delved into the concept of really big x's or really small x's, and we will hit that very very much in the next unit, unit 5. But here's what we can make this statement. As x gets big, as x approaches infinity, this particular polynomial, which is ax to the n plus bx to the n minus 1, ... all the way ex to the 0, that thing is going to look like this, and this is just subscript, f subscript 1. So as x gets big, f of x is going to behave and look like its power function. In fact, this is the power function, ax to the n is the power function for this big long polynomial right here. And as x goes to negative infinity, the same thing is going to happen. The function is going to approach its power function. Okay, they're not the same, but they will appear that. And that's something that you can really this, oh my goodness gracious, this is something that we've been doing for a long time, is finding the average rates of change of a function. It's always this. This is the average rate of change from x equals a to x equals b. This, I think, was copy and pasted from the quadratic function unit. If f of x increases from x equals a to x equals b, then this average rate of change is greater than 0, and we say that on average f of x increases y units per x unit. If f of x decreases, the average rate of change is going to be negative, and we say that on average f of x decreases the absolute value y units per x unit. So this has not changed, and this will never change. This is true actually for all functions. So let us take a moment, get your graphing utility out, and let's go over example 1. I will let you try example number 1. Find the x-intercepts, find the y-intercepts, find the power function, and we're going to sketch the function. Okay, hopefully we have a nice example here. So give this guy a whirl. So this will be a good example to demo how to find x-intercepts, y-intercepts, minimums, and maximums. This is a nice function. If I look at it on a standard window, it has a min and a max. Looks like it has 3 x-intercepts, certainly just 1 y-intercept, and 1 min and 1 max. So I'm going to find the first x-intercept. I am recording this in case we need help with that. The first, it's going to be the 0. I'm going to arrow over here. I want to get to the left of that 0, push enter. I want to get to the right of that 0, push enter, bam. And this is my first x-intercept right there. I'm going to find the other x-intercept. Go for this guy again. To the left of that x-intercept. Go to the right of that x-intercept. Left bound, yes. Right bound, yes, yes. And here's my second x-intercept as x equals -1. I'm going to find the third x-intercept, 0. To the left of that rascal. Bam. 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 And this is the 1.3507. Make sure we write those. I want to find the maximum point. 4 for max. Arrow over to the left on the max. Just in case we need a review for this, I'm walking through it, actually videoing it. Bam. Bam. The max is going to be -1.4574, comma 1.0105. Find the min. 3 for min. I trust that all of you can do this. Looks like I'm to the left. To the right. Hopefully I'm to the left. Yes. 0.4574, -6.0105. And now I'm going to take all that information and put it on my particular notebook. I have the x-intercepts are going to be -1.8507, comma 0. I'm going to have to add some more. Put it up here. -1, comma 0, and 1.3507, comma 0. I'm going to plot those daggone points. Let's see here. I'm going to plot this guy, this dude right here. The y-intercept is going to be easy. You're just going to put 0 in for x. That's going to be 0, -5. It's going to be down here. The maximum I had was this dude right here, -1.4575, comma 1.0105. The min looks like it was 0.4574, comma -6.0105. Power function is easy. The power function is simply 2x cubed. Here's what math students generally, elementary math students, they want to grid everything out. You don't have to scale everything out. Just give a general shape of that. And this daggone thing here. How does it begin? What's the end behavior? Well, f of x. We better write this down. We're going to talk about end behavior. F of x starts positive. And why does it start positive? Since n, the degree, and let's write it as the degree, since the degree is odd, since the degree of 3 is odd, and the leading coefficient there, 2, is greater than 0. So that guy's going to start positive and end, it starts negative. Maybe I should have looked at my notes. This guy starts negative and ends positive. So this graph is going to look like this. Let's do the graph in this pretty purple. I have this maximum point. Come down here, I have the y-intercept, and the minimum is just to the left of that y-intercept. And this is that graph right there. This is the graph of f of x. Okay? Let's talk about this increasing, decreasing thing right here. Therefore, the graph, let's see here. If I have the minimum point right here, I have this minimum point labeled right here, 3.3094, comma, negative 24.6336, and then I have this max up here. Therefore, and we talked about this guy increases from negative infinity. Negative infinity is over here, so it's going to increase, and we know this guy starts negative and ends positive. It starts negative because it's going to look like x cubed. The leading coefficient, the degree is odd. The leading coefficient is 1. So this guy is going to start a negative and end positive. And it has a minimum here and a maximum here, so it increases from negative infinity to this x value, which is negative 1.309, and it decreases from here to here. And I think we talked about that as well, just to review that a little bit. So you're going to be asked to describe intervals of increasing and decreasing. And I think we did most of, obviously we did most of this example. I'll allow you to find the minimums and maximum points here on this particular guy. This might be a little bit, and let's put this guy into our graphing calculator. True or false? We did not do this with our graphing calculator, right? We didn't. All right, so let's put this guy in there in our graphing calculator, because we might have to drastically look at the different, change the window. And we do need, since this guy is in factored form, and there were true or false, so we put this guy, we just kind of gave a rough sketch using the x-intercepts of this guy. We did a rough sketch looking at the x-intercepts. We're going to put this bad boy in our graphing calculator right now, and we're going to find the two mins and the max. So I've changed the window once. I changed the window to where the y's are from negative 50 to 50. I've looked at the graph. I can see the max and the min. I'm going to find this max and min. That's the maximum point. Second, calculate option 4. Left, right, bam, enter. I'm going to find the min, the second min, actually. Go to the left, bam, go to the right, bam, bam, and that's the min. Here's your sketch here's a nice sketch of the graph, and we can see that it does indeed start positive. And mins, maxes, mins, and ends positive. Our window is set at negative 10 to 10, negative 125 to 50. And we're going to find this new min. So this guy, using the max and mins, I didn't label my graphs. I could if I wanted to. I have them written down here. This guy right here is negative 3.6526. This guy right here is positive 2.2145. This dude right here that's the y-intercept, but I think the maximum was over here at negative 0.0618. And so so it increases from here to here. And it's going to decrease from here to here. So it decreases from negative infinity, and you can't say from x equal. This is a no. No, you cannot say x equals infinity, because that is you can't say this. You just have to say from some x value to infinity, from negative infinity, and you go from negative infinity to this guy right here, x equal negative 3.6526. And where else does it decrease from? From x equals negative 0.0618 to x equal 2.2145. Okay? So we're going to find the average rate of change from x equals 3 to x equals 5. We're going to find this. We're going to use our calculator to find this. And then this is going to be our verbal description. So we're going to go to our calculator and find this particular value. I found this with my graphing calculator, and this number is equal to 240. So what's happening? On average, from x equals 3 to x equals 5, f of x increases 240 y units per x unit. Think about that with respect to this graph. Think about what the heck that is talking about. That is saying that this graph, if I look at the graph down here, let's look at it with my graphing calculator. That means if I'm over here from 3 to 5, let's get some more y's. I'm going to go to 100. Oh, poop. What'd you do that for? I don't know. I'm going to go 100 y's. What I found, if I go from 3 to, let's see what was that value at 5. That value at 5 was 480, so I'm going to go 500 y's. So I can get that in there, and I'll show you exactly what that means graphically. So what I did is I looked at the average rate of change from 3 to this 5 value right here. That's the slope of that line, and that is a very, 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 very steep line. It goes up 280 and over 2. That's what you're doing when you're finding the average rates of change. So I think we are ready for